calculator here to do this. Thank you. And you guys might have some data in here. I'm just going to, give me 1 second. I'm going to clear mine out so I can start fresh here. Okay, so you're going to want to hit the button that says Stat. And I know we've used this before, but it's probably been a while. And that should, if you hit that button, just Stat, it's 2 down from the zoom button, kind of right in the middle there. So just hit Stat, and it should automatically take you to this menu I've got up on the screen here. And we're going to input the data. So where it says Edit there on number 1, all you're going to do is hit Enter there. Okay, and then it should take you to a screen with a bunch of columns. Now, does anybody's not start with L1? Does anybody say like L2 or anything like that? Because people can delete a list on accident. Okay, now what you want to do in that L1 stands for list 1 is I'm just going to type the data values for these lengths of these tornadoes. So I'm just going to type data. And you do have to hit enter in between each one. So I'm just going to type these tornadoes. I'll just enter after each one. There should be 16 of them. If you're looking on the screen there, it'll say in the bottom left corner L1 and then whatever data value you're on. So on mine, I'm on the 4th one. So I just kind of go back and spot check maybe after I've typed them in that I didn't mess anything up or I didn't skip anything, but you should end up with 16 values in here. And even after you do the last one, you have to hit enter. And then you can use the arrow keys to scroll up and down if you want to just go back and check you didn't mistype anything or anything like that. It's easy to do that. So I'm just going back up to check real quick. And after you got those guys all typed in, you're going to hit the Stat button again. And this time when you're in that screen, across the top, you want to arrow across to a menu that says Calc for Calculate. And we're literally just going to pick the very first thing. It's 1-variable stats. So this is just saying I'm only using one set of data values. So 1 VAR stats stands for 1 variable stats. All you got to do is hit enter. Now, depending on the type of calculator that you have, it might bring up the screen, it might not. What you want to do, and if you have this screen, I would just check real quick. We want to do the statistics for list 1. So if that doesn't say list 1 there, if you hit second and then the number 1 down here, sorry if you can see it, you can change what list you want it to find the values for. But if it's already at list 1, we're good. Just keep hitting enter then, and then eventually all those statistics will show up for you. So we don't have to calculate them by hand. Okay, now, if you remember from yesterday, that X bar, it's the very first thing. That is the calculator abbreviation, or it's an accepted variable that represents the mean. And I'm just going to go 1 decimal place on here. So about the average path of destruction for these tornadoes here is about 12.8 miles. I'm just going to do just 1 decimal place for this. Okay, now there's other information here we're not going to use today. So just kind of skip down. The N just tells you the number of data values, so that should be 16. And if you just use your down arrow, just going to scroll down here, that 5-number summary should be in here that we talked about yesterday. So the minimum, which you could probably figure that out from looking at the data set, but the first quartile, the median, the second quartile, instead of calculating and counting in by hand, the calculator will do all of that for you. So your lower quartile, or Q1, that is 6.5. Your median, if you typed all these data values in, right, should be 8.5, or that's also called the second quartile. Third quartile, or upper quartile, that one's going to be 15. The maximum data value is 39. And this can be really useful to use the calculator, especially like here, if you look at the list of tornadoes, they didn't list them in order from least to greatest or anything like that. So it's nice to have the calculator to just do that for you and calculate those values. Now, the two things that I put on this list that the calculator will not display, will not do a mode, and it will not do an interquartile range. So those two you'd have to calculate yourself. It also won't tell you the range of the data. I didn't ask for that here, but the range would just be the maximum minus the minimum. So the mode, if you remember, is most often. Can anybody look at those data values and tell me the mode for this data set? So, the most often. So like any of these repeated. Okay, now 7 is a mode. Does anybody else see something? Okay, 7 appears twice, 8 appears twice. It is possible for a data set to have more than one mode. Basically, if you have repeated data values, if there's not one, if we had 15 is actually on there too. So all three of these, 7, 8, and 15, there were two different tornadoes that had a path that were 7, 8, and 15 miles. So they all appear twice. So you have 3 modes for this data set. No, that doesn't matter. You can just list them. And the interquartile range, this is going to actually become important for calculating, calculating outliers. So interquartile range is your upper quartile, which is Q3, minus your lower quartile or your first quartile, which is Q1, which I can just grab from that data we just wrote down. So this is going to be 15 minus 6.5. And I'm not trying to be confusing or anything. It does end up being 8.5, which also happens to be the median in that example, but that's just a coincidence.
So it's not always like that?
No, it's not always the median. It's always the Q3 minus the Q1. It just, in this example, they end up being the same number. Okay, now once you're there, we're going to calculate some outliers, and you might be able to look at the data and kind of figure this out just kind of based on instinct, but there is an actual formula to calculate an outlier. So an outlier is a data value, or it could be more than one, so it says value or values, that is substantially different from the rest of the data set. Now, to calculate the substantially different part, on the lower end of the data, the way you calculate any outliers on the lower end, it is your first quartile, that Q1, minus 1.5, this is just a formula, times the interquartile range. So that's just a formula. And I'll give you guys this, any test, quiz, final, anything like that, we'll give you these formulas. Okay, and then on the upper end, you want to exclude any number that is above Q3. Now, on the upper end, you do Q3 plus 1.5 times the interquartile range. So on the lower end, it's first quartile minus 1.5 IQR. On the upper end, it's Q3 plus 1.5 IQR. So that would be different there for every data set, but we're going to calculate it for ours here real quick. So I'm going to exclude any number below what we call the lower bound. So for our data set, the Q1, let's see, is 6.5 minus 1.5 times my interquartile range, which is 8.5. Now, when you guys do this, and sometimes this happens, so this is a good example here. If I do 6.5 minus, I should have told you guys, if you were in that stat screen, like you were looking at that, if you hit second and then the mode button right next to it, second, the second function on that is to quit. That'll take you back to the main screen. So if you're stuck in a screen, just hit second, quit, and that'll take you back to the main screen if you're not there. But I'm just going to type this in real quick, that 1.5 IQR subtracted from my first quartile. Now, this ends up actually being a negative number here. If you look at the data set we had, the lowest number on that data set was 1. So what this is going to mean to me is I have no outliers on the lower end for this particular example. So I don't have any data values that are negative at all. So there's just not going to be any outliers on the lower end. On the upper end, you're going to do the third quartile, which for this example was 15, On the upper end, you add 1.5 times the interquartile range, which is 8.5, just grabbing that from the data. So 15 plus 1.5 times 8.5. And we want to exclude any number that we see that's above this value. So I got 27.75. So on the upper end, if you're looking back at the data, do you guys see any numbers that are bigger than 27.75 on that list for those tornadoes?
39.
There's actually two. 37 and 39 are both larger than that upper bound. So those would both be outliers in that case. Okay, now what I'm going to have you do here, I'm going to have you recalculate the mean and that 5-number summary, but we're going to remove the outliers. And there's just a real quick way to do that. So if you just go back to stat real quick, and I'm going to go to the edit, and we had all those tornadoes already listed for ourselves. You can actually, instead of retyping this, I'm just going to use the arrow key, and I'm going to delete the outliers. Now, you can't hit the clear button, will not work here. You have to use the delete key. It's right under the zoom button. It says DEL. If you just delete, that'll literally just take out that one data value, and then I'm just going to arrow down to the 39, and I'm going to just delete that one data value. And there I removed my outliers. So to recalculate our 5-number summary and our mean, we're just going to hit stat, go over to that calc menu, and then that very first thing, the one variable statistics, that's the first one you want. Just keep hitting enter until it shows up. And then you might have to scroll down to the bottom a little bit, but the mean is at the very top. The mean, I'm just going to go 1 decimal place. Now, instead of my mean being 12.8, now it's 9.2 if I remove those outliers. And then to go down to the bottom, the very last 5 things should be your 5-number summary. So the minimum is still 1 because we didn't have any outliers on the lower end. But now our first quartile is just 6. Our median is also different. Our median is 8. Our Q3 is 13. And now the maximum, once we remove those outliers, the maximum is 22. And what I'm going to have you do is I'm going to have us draw a box plot for each of those just so we can see how removing the outliers changes that visually. Okay, so I'm going to go ahead and I'm going to use the first number line here to just do the original data set that we had. Okay, so on the original data set, the minimum was 1. And the maximum was 39. And if these are not a nice number, just do your best to estimate. So my Q1, that would be the left side of your rectangle for your box, 6.5. So I'm just going to do my best to come right between 6 and 7. Each one of the tick marks here is just 1. And let's see, the median is 8.5. So I'm going to do my best to come between the 8 and the 9. And then the Q3 is 15, so that's actually trying to do my best to get close to the 15. Then I'm just going to create my box and then draw my whiskers. And you guys can see in that case the data is spread out over that entire number line. Now if we remove the outliers, it's going to condense the data and put it more in a smaller location. So I'm going to use these numbers right here above where we removed the outliers to redraw. Okay, my minimum is still 1, but now my maximum is only 22. So the whole box and whiskers plot is going to be between those two numbers. Now, the Q1, the Q2, and the Q3 are actually kind of similar to the original. They're just a little bit different. This one, the Q1 is 6. Q2, which is the median, is 8. And Q3, which is the third quartile, is going to be 13. So you can see, usually when you remove the outliers, it's a better representation of the rest of the data. Is anybody having a question? Okay, now what we're going to do on the back, we're going to calculate, this is still with the data set, but we're going to calculate something a little different. We're going to calculate percentiles here. Okay, so percentile has to be a number from 0 to 100. This is not like a probability where you can write it 16 different ways as a fraction, as a decimal, as a percent. It has to be some number between 0 and 100, and you can associate that number with a value. They're going to use x in my little definition here from the data set. So x would just represent one of your data values. Okay, now the percentile is going to show, so it shows the percent of data that are less than or equal to x. So just as a tiny example underneath, it says if x is at the 90th percentile. That just means 90% of the data are less than or equal to x. A lot of times they use percentiles to describe, like if you take a little kid to the pediatrician and they measure the kid's height and they say, okay, the kid's in the 85th percentile. That just means they're taller than 85% of the kids their age. That's what that means. Okay, now there's two things we're going to do with calculating these. And so the first one is how to calculate what data value out of the set is a certain percentile. Okay, so to do that, what you're going to do, you're going to take the percent, and I would do it as a decimal. And you're going to multiply that by whatever the number of data values, I'm going to write number of data in set. So like if I have a list of 50 data pieces, that would be 50 is what I would plug in there. And that, when you multiply that together, will tell you the place. And that'll make more sense in a second. But the other key to this, no matter what the number is, you round down. So if you got like 35.8, that would be rounded down to 35. So whenever you get this, you always round the number down. No matter what the decimal is, round the number down. Now, the one thing is slightly annoying about these, and I did put these data in order. This is 25 test scores. You have to actually write down what place each of the test scores is. So what I mean by that, I've got 25 test scores. They're written from least to greatest. So the person that got the 43, that would be the first position or place 1. The 54 would be 2. And so I'm just going to, each one of these, I'm just going to put a number under on down the line. There should be 25 of them. So I'm just writing the position or the place in the data set that falls. So that's where that's at out of 25. All right, to calculate these percentiles, here's all you're going to do. So the 90th percentile. So I want you to think of like 90%. All right, so 90% of the data values are going to be less than this value when we get it. So 90% as a decimal would be what? 0.9. Okay, so you're just going to take 0.9. Now, we got 25 test scores here, so I'm going to take that times however many data values I have, which is 25 here. And sometimes it's a nice number, sometimes it's not. It just kind of depends on the question. So this ends up being 22.5. Now, a normal person would round that to 23, but when you're working with percentiles, no matter what, you always round down. So I'm going to round that down. So this is going to talk about the 22nd place in the list is going to be the score that's better than 90% of the rest of the class. So what you want to do, just come up to this list, right? Find that number right where you wrote the 22. So that person that got the 96 is going to be the answer to the question here. That person is getting a better score than 90% of the class. Okay, if you want to calculate here the 20th percentile. So 20% would be 0.2. Just multiply that by 25. This is actually a nice number. This is just literally the number 5. So that just means you're going to go to the 5th place in that list. And so whatever that score is, that's going to be your 20th percentile. So that person got a better score than 20% of the rest of that class. So in this case, that's going to be 62. If you want to calculate the 50th percentile, you're just going to do 0.5 times 25. Now, this is another one we're going to round. So this will be 12.5. So you always round down, even if it's like a 0.8 or 0.9. So this would be the 12th place. And if I come back up here, the 12th place is a score of 72. So the person that got the 72 got better than 50% of the rest of the class. Anybody have any questions? Okay, I'm going to scooch this up a little bit. Now, the other thing you might be asked to do, this says how to determine the percentile for a given value. So if I give you one of these test scores, could you tell me what the percentage or what the percentile is? So to calculate that, what you're going to do, this will be a fraction. You're going to do the position or the place of the data value. So like if I picked 67 out of that list that you're looking up here, if I pick 67, the number I would put on top of this fraction would be 7. Okay, the position of the data value divided by the number of data values. So divide by the total number. For our example, I got 25 test scores, so the bottom of that fraction would be 25. But I'm going to do one more thing here. You're going to take whatever that is, because that'll give you a decimal. You multiply that by 100, and that will tell you what the percentile is. So it'll be a fraction. We'll multiply it by 100. That'll tell us the percentile. Okay, and then the one little thing I wrote here, which we're going to run into this in this next example. It says if a data value appears more than once in the set. So if you look up here, a couple of these test scores are repeated, like a couple different people got the same score. Okay, if that's the case, you always want to choose the data value for the position farthest to the right. So if you've got a score here for our test scores, if there's more than one person that got that score, you pick the person that's farthest to the right when you pick the position. Okay, so let me, and I should have scrunched this so we could see these at the same time. If you guys look down at example 4, we're going to find what percentile is the score of. The first one they list is 70. So I'm just pulling this down so you guys can see it. 70 is in the 10th position of this list. Okay, so to calculate your percentile, I'm just going to come down here. This is just 10 out of 25. And then you multiply that by 100. That'll give you your percentile. So just 10 divided by 25, multiplied by 100. This would be the 40th percentile. Okay, if you look up at the list, 93, where does the 93 fall? What is the place for 93? You got 20, right? So just do 20 out of 25. And multiply that by 100. And they're not, my first couple examples I think are nice numbers, but that's not always the case. So this is the 80th percentile. So that means 93 is better than 80% of the rest of the class. Okay, now these last two, this is why I put that little asterisk right above this. Okay, so the next one they asked you for is 88. If you guys look in the list, I got 2 different people that got an 88. You always go with the person that is farthest to the right when you calculate a percentile. So the furthest to the right would be position 18. So when you do this, we're going to do 18 out of 25. Multiply that by 100. And this would be, I got 70.72, 72 if you multiply it by 100, so that's the 72nd percentile. And I got one more, 62. And also, this is actually kind of the backwards of what we did here in the example in the middle, right underneath the data set. It said calculate the 20th percentile, and we got 62. So we should get that as our answer. So again, you got 2 different people that got that score. You go with the person farthest to the right when you write down the position. So I've got 4 and 5. You go with the bigger number there. So 5th position. So 5 divided by 25. Multiply that by 100. That should be 0.2, and then multiply by 100 is 20. So that'll be the 20. Oh, I'm really crooked there, sorry. That'll be the 20th percentile. Is anybody having a question?